This is another video demonstration. This one will be on a pressure sensing system developed by Rushford Conductive Nanofiber and their deposition process. This happens to be a thin film that was created using a aramid substrate. That's what you see, about 4 inches long and 1 inch wide. And the aramid substrate is infused with carbon nanotubes using the deposition process that they've got. As you can see, it's the aramid material is embedded in a plastic laminate, and it's fairly flexible. We've mounted these sensor materials on aluminum plates. Here you can see the silver epoxied contacts or electrodes that we've put the wires on, and we've taped the substrate down on the aluminum plate. And we've also, put some tape over the top of the electrodes to keep the wires secure and not allow them to help not get them caught on things and have them ripped off. I've placed a piece of rubber over the top of the substrate, and that just helps even the pressure out a little bit on the sensor, and it might also help protect it a little bit. Not that it really needs that much protection. And then we read the value of the sensor using a standard, well, it's not really standard, but it's a Bluetooth enabled multimeter. So together with this Bluetooth enabled multimeter and then this Android device, actually it'll also work on a Apple iOS unit as well. You've got a complete pressure sensing system here. Here again, we've got our plate with the sensor material on it, the electrodes, the rubber membrane material, and it's wired into our Bluetooth enabled pressure sensor or a data acquisition type device, a multimeter. And right now we are on a 5 ohm division scale, and it's basically riding on a 150 ohm resistance reading, 150.145 it looks like, and it's going up and down a little bit. If I were to put some pressure on this now, you'll see that it reacts to it, and now the scale has just changed. So now we're at a 50 ohm per division scale, and my index finger is pushing down on it. Use a thumb here, and then I'll even get more deflection. So like right now, I've been changing a couple hundred ohms now, sometimes more, sometimes less. I can put my whole hand down here and I change the scale again. And there we go, putting pressure down, releasing, putting pressure down, releasing, and I change it again. Now the scale is at a 500 ohm per division scale. So let's put a standard rubber stopper number 9 40 durometer, and let's see what we can do with this. And here you can see we're changing the deflection of about 600-700 ohms by me putting pressure and releasing, pressure and releasing. Then we've got a force gauge meter here. The meter is upside down, but hopefully you can read it. Right now I got 2.5 roughly pounds of pressure applied. Let's see what we can do with going up and down on this. 15, back up, 15, back up to about 2. It's almost 0. So as you can see, it pretty well tracks with the force gauge meter here. Sorry that it's upside down. Yep. So that concludes our test. I hope you liked our demonstration. Thank you very much.